Hello, Tony. Oh,
Hi, Yuxi.
Hi. Oh, Hello, everybody. Yeah. 对，我这个眼睛今天有点感染了，然后我就不准备放那个视频了。
Oh, okay. No problem.
有点破相，
希望赶紧好。
好啊。
Hi, 李航。
我马上回来。
Okay.
我看一下啊，先把我那个在这里。可以了吧？
可以看到，可以看到。
OK， 好。
Tony，我觉得你可以8点59左右就开始介绍老师，然后就开始就行。
哦，好的，没问题。
哎，等一下，那个问题环节是让李航来组织是吗？还是怎么样？
会先让有一个 Q&A section， 然后如果有问题的话就可能您需要看一下那个chat 里边的问题，然后回答一下，之后就是李航老师进行他的 discussion。
我这个看chat 怎么看？OK， 看到了，就可以了。
哎，李恒老师进来了吗？
进来了。
我这个 Q&A 为什么点开之后看不到内容呢？
因为现在 no question posed， 所以就是我现在可以改一下，就是 all question， 就是都可以看到。
OK， 没有问题，我就试一下。
对，等一下，我也会一起看一下那个chat 跟 Q&A 里面有问题的话，我可以一起把它读出来。Okay, I think it's time to start.
Oh yeah.
Jerry, so it's good to go, right?
Yes.
Cool.
Go ahead.
Yeah. Hi everyone. Welcome back to our Applied Reinforcement Learning Seminar series. So today we are very excited to have Yuxi Li and Li Hanying for our talk and discussion today. So Yuxi will be presenting reinforcement learning applications. Yuxi is the author of the well-known 150 pages Deep Reinforcement Learning and Overview survey, which is all available at the link in our introduction page. And this is a report that that's highly recommended to all the researchers and practitioners in the industry as well as academia, whether you are already working on reinforcement learning or thinking about going to the domain. Yuxi is right now writing a book about reinforcement learning applications. He is the lead guest editor for a machine learning special issue, the lead co-chairs for ICML 2019 workshop and a 2020 virtual workshop, or on reinforcement learning for real life. He was a co-organizer for AI Frontiers conference in Silicon Valley in 2017 and 2018. He has published refereed papers at venues such as NeurIPS, AI Stats, and Infocom. He serves as TPC members and reviewers for conferences and journals like AAAI from 2019 to 2021, ACM Computer Surveys, TKDD, and PLOS1. He obtained a PhD in computer science from the University of Alberta and was a postdoc there. He was an associate professor in China and a senior data scientist in the US. He founded Attend.ai in Canada. Our discussion leader, Li Hangyin, is the president of Alberta AI Association. Welcome both. So let's hand the control to Yuxi. It's all yours now.
Okay, is that good? Okay.
Yeah.
Yeah. Thank you for the kind introduction, and thanks very much for the invitation. It's my honor, and it's great to share with you my understanding of reinforcement learning applications. Actually, this is basically an overview of this this area, and so I will cover many topics, and let's see how it goes. Okay. Yeah, so AlphaGo, I think everybody knows. I saw this picture and I won't say too much about it. And reinforcement learning, I think most people know this, but this is a reinforcement learning talk, so I will discuss it very briefly. So in the reinforcement learning architecture or scheme, we have agent, and at every step, it receives a state, select action, and receive a reward, and then transition to next state. And the objective is to maximize the long-term reward. You can see this is actually a very general scheme, so it can formulate many problems. Actually, this reinforcement learning, this word is from classical conditioning. Probably everybody knows that the Pavlov dog experiment. So it's basically from that experiment. And maybe you also know that Sutton, the people call him the father of reinforcement learning. He got a bachelor from psychology from Stanford University, his first degree. And reinforcement learning is widely related to many fields. For sure, it's part of machine learning. Usually, we see that. And it's also related to like optimal control, like operation research, and also just like we said just now, classical conditioning and rationality, game theory, and also computer science, engineering, mathematics, economics, neuroscience, psychology. In Sutton and Barthel's new book, there are 2 chapters talking about neuroscience and psychology, and yeah, there are some interactions between this field with reinforcement learning, especially DeepMind. DeepMind, they are doing quite some work on the interaction between neuroscience and reinforcement learning. That's a very interesting direction for both fields. Yeah, this is a very brief overview of reinforcement learning, deep learning, super learning, and super learning, machine learning, AI. And yeah, if you are interested, you can check my overview. Yeah. And last year, David Silver gave a talk. It's talk about deep reinforcement learning from AlphaGo to AlphaStock. And some time ago, he gave a kind of conjecture: reinforcement learning plus deep learning is AI. So in this talk, he gave some discussion about this, why he said so. So basically, he said something like, reinforcement learning is enough to formalize the problem of intelligence. And deep neural net can represent and learn any computable function. And so reinforcement learning and deep learning can solve the problem of intelligence. But he called this conjectures, so I think it's debatable. Yeah, so although I trust it. So recently, this wave of deep reinforcement learning basically started with the deep Q network. Basically, they have a single architecture and a single algorithm, and they can play. At that time, I think it's 40 some games, but now there are 57 games. And after that, that's in 2013, but they published a paper in Nature in 2015, and then people working on this a lot. And you can see this is basically a representation of the progress of this field. Basically, it's about something called value-based reinforcement learning. So from DQN, and people do double DQN and like dueling, and also like putting short-term memories and put episodic memories and exploration techniques. And recently, meta controllers, they can control when to explore, when to exploit. Make it intelligently select the exploration versus exploitation. And then they have this Agent 57, and for using these algorithms, they can achieve the superhuman performance on all the 57 games. And they are using a new performance metric that is fifth percentile performance. Before this, people usually use average. So for average, just like two people, one is very rich, one is poor, but the average, make the poor looks like rich, but that's not reasonable. So, but for this fifth percentile performance, basically they are looking for the worst, the fifth percentile worst. So, but even on this percentile, on this performance metrics, Agent 57 can achieve very good results. But some previous metrics algorithms, they are not doing very well. Actually, this paper I highly recommend if you are either new or even some experience in reinforcement learning. This paper is basically a very good recent one, and it covers basically it absorbs the excellence of the progress in this I call it subfield about value-based reinforcement learning. So I think this paper is highly recommended. If you are a PhD supervisor, or if you are a manager and you want to ask your say student or colleagues working on something, maybe you can just give him this paper and him or her this paper and ask her or him, okay, look at those paper and start working on this. I think that's maybe that's a very easy thing to do. Yeah. This is about AlphaGo. There are some details. For sure, I won't talk too much, but basically, I just want to say, AlphaGo is basically based on deep learning, reinforcement learning, Monte Carlo tree search, and it's using something called a policy general policy iteration. So it's by default, this is for AlphaGo 0. So it starts from scratch and using self play. So it forms some very random policy and then do this iteration many times, and then it converts to some very good solution. So it can be like listo, like many top players in the Go. Yeah, so this is the landmark, and yeah, that's very good. And I very briefly talk about several recent achievement. Like the first one is StarCraft, second one poker, and this one is curling. They are doing curling on robots, and this is catch flag, and this is something called hide and seek. Recently, there is a talk about this hide and seek, and I think that's very interesting to watch. They can, all these papers, I think, very interesting, and they achieve very strong results. And for this hide and seek, since there are some videos, and they can show some very interesting or funny strategies the players can achieve during the learning of the reinforcement learning. Yeah, so it's interesting to watch them. Yeah, so since we are talking about applications and we are talking about those games, and so the authors of those papers, they recommend the potential applications of those techniques in games. Actually, if you can see those, actually they are very, very general. For example, for the AlphaGo paper, they mentioned like general game playing, like classical planning, like scheduling, like constraint satisfaction. Actually, these are very general problems. So they cover many problems in computer science, in open research, in combinatorial optimization. So, so I think basically games to AI is like fruit flies to genetics. So that's why people study games, spend so much time on games. That's a very good testbed for AI algorithms, and it's a stepstone to make progress in AI. So we can see there are lots of if we can do good in games, those techniques can be applied somehow easily to other applications. So that's we should try them when conditions become ready. Yeah, the conditions I will talk a little bit at the end. Basically, I think at this stage, I think it's about resources. Yeah, there's recently a book. It's about the English is reality is broken, and when you see this explanation, it says what games makes us better and how they can change the world. This is about gamification, especially we treat actually many things we can treat them as games. So when we have very good techniques to solving games, then many things in our life can be treated as game, and then we can find some way to solve those problems. So the game can change the world. That's the Chinese translation. Okay, so we talk about very briefly about the recent achievement and like how to what kind of application they may have. Very briefly, very style. Actually, I don't know if we yeah, I think we put the question at the end, but I think for me it's okay to ask questions during the talk. So there's a break. Before going to the next topic, I will talk about some recent achievement still very briefly, since I put lots of things in these slides. And yeah, so yeah, this is about multi-unbounded. Recently, Microsoft, they have done something, and they have done some experiments, and for some problems they have 25 to 30% improvement for click-through rate, for say recommendation, news or advertisement, and they have 18% revenue leap in the landing page, for some app. For the app, before the app, the launching of the app, they can put some ads there, and if using these multi-unbounded techniques, they can achieve much better results. And actually, multi-unbounded is a very general technique also, and it's a specialized reinforcement learning. And they put several specific applications like news website recommendation, technical support assistant, cloud controller. So this is a one-page introduction about this technique. It's from Chaba Zepsbury. Basically, we have K-arms. We go n rounds, and in any round we choose the arm. The arm generate a reward and observe the reward and repeat. And the goal is to maximize the total reward. Yeah, if you can remember, this is very similar to the reinforcement learning definition. The major difference is there's no transition from state to state, and but something like there's a puzzle observation problem, and there is also a problem about delayed reward. Just for example, when we do recommendation for the news article, we recommend some news, but the reader may click after several seconds or after several minutes or even after 1 hour. So when we want to, machine learning or reinforcement learning is basically data driven. So we need to collect the full data before we can train our algorithms and then deploy them. So, but when we observe partial data and when we observe delay data, so people need to handle these problems. But yeah, so maybe I say this. Since just now I mentioned these problems, and so if we have those problems, then we have some possible potential failures, like feedback, partial feedback and bias, and incorrect data collection, and changes in the environment, and weak monitoring and debugging. So Microsoft, they designed this decision service. They make abstractions like explore, log, learn, and deploy, and then they implement this in the system, and then they try to address those failures. And they also design something called multi-word testing, and this is basically comparing with the classical A/B testing. When we want to try if this option is good one, we want to try some other options, and then one way is to do A/B testing. We divide the percentage of users on both options and try them online. But for the multi-word testing, we can use these kinds of contextual bounded and policy evaluation techniques, and then we can test many policies. Even some policy we don't know, but we can test them. So this is multi-word testing. So that's exponentially efficient than the A/B testing. So I think that's something worth further study. So they designed this decision service, and then they have many applications from the Microsoft. This is basically on a blog from Microsoft late last year. Actually, also there are many applications, many publications, and they also organize workshops about their, especially about their achievement, like the personalizer, and they applied in their inside Microsoft in product and services. They also apply them to the all over the world. Microsoft is a international company, so I think that's a very interesting. And then they achieve this inaugural ACM SIG AI Industry Award for excellence in AI. So yeah, I think that's, and for this work, I think one thing very interesting is it's about it's about a real system. It's not only about algorithms; it's also about deployment. Many say software engineering problems. So if we are talking about reinforcement learning applications, I think this paper is a very interesting one to look at. And also, they put decision service, they put the open source on the website, and also, since this is already a service from Microsoft, so they have documents on their website. So this is I think this is a customer inside Microsoft. They are using this. They are doing something based on the decision service, and they are working on some Microsoft virtual agent for intent disambiguation and contextual recommendations. And they are doing those things, and they summarize lessons from using this contextual bandit. And yeah, for the time reason, I won't discuss those things in detail, but you can check the references. I think this is also very helpful, especially you are working on realistic applications of reinforcement learning. There are many pitfalls, lessons to learn from. Yeah, this is from DiDi, and the first author is here. So Tony, so I won't say too much to avoid making mistakes. But you are this is they are working on this for several years. I know I discussed with them, and they obtained this reward. It's a premier reward from from the ARL and the monument system so this is a very good reward. And actually, when I have a friend in ARL working on like routing, like these community optimization, when he knows that some people basically Chinese people achieve this reward, he was very excited and kind of surprised. So that means this is very good. And there is recently a paper by Qin and his colleagues summarizing this result, and Tony Qin also gave several times the tutorials about this, and also there's a talk from Tony in this applied reinforcement learning seminar series. So you're welcome to check that out. There's recently about autonomous navigation of stratosphere balloon using reinforcement learning. I think this is a very interesting research. Using reinforcement learning to work on some realistic applications. But just a couple of days ago, I found that there's a news from this company. It's kind of I think this is a part of the alphabet, this loon, and they already said goodbye to this project and this company. Yeah, I think there are some issues, not about techniques, but about some, like how to commercialize those things, how to make money out of those techniques. But technique-wise, I think this is very interesting work. And recently there are work about robotics for robots to work in very challenging terrains, and there are some techniques. It's not only about people already know. People probably know the from simulation to reality. There's a gap, and they are trying some additional techniques like imitative learning, like they call privileged information to learn something, and then try the imitative learning, and then they do from the simulation to reality, but they can achieve a very good result. So that's also interesting for robotics. And recently there's work about for the system, computer system. You can see that from this they put summarize the result in a table. You can see that quickly look at those enrollment, that different topics in various topics in computer science, from video streaming, job scheduling, database network, to circuit design, to say switch scheduling, to say memory caching. So it's basically many topics in computer systems. That's basically says reinforcement learning can solve many problems. Actually, in systems in networking, many problems are decision making problems, and reinforcement learning is a natural solution for those problems. Okay, very recently there's a paper about multi-agent reinforcement learning training school for autonomous driving. This is basically a simulation. This is a test bed. But autonomous driving is kind of hot topic these days, and they are. I think all people, or most people, they are from Huawei, and they deliver this open source environment, and so this is interesting environment for people to try. Say multi-agent reinforcement learning algorithms for this autonomous driving scenario, and see how reinforcement learning can help this scenario. Another work is about game test. So people from several places, from Tianjin University, from NetEase, and I think other places, they design algorithms and test the games. Games, I think, is also kind of the software system. So if we can test games, then we can also test computer software system. So I think for this one, it's about computer systems, and it's both hardware and software, and this games is a specialized software problem. So, and this achieve a good HM6 soft distinguished paper about. There are, I think this year's there are many papers from there are many papers about reinforcement learning achieve many kinds of reward. Like, we mentioned several just now, and there are many, like batch papers in conferences. Many of them are from reinforcement learning. So that's a burgeoning field of this. Or maybe call it renaissance of reinforcement learning. And this one is about, actually there's a big survey paper, maybe 90 pages or something. It's about instructional sequence. It's about, education. And actually education and AI, they are working together for a long time. And recently people trying reinforcement for this, and they are achieving some good result. And some takeaway they gave, if reinforcement can work together with some series from cognitive psychology and learning sciences, then the results are usually good. And this is also about reinforcement learning, and it's about education and reinforcement learning. It's about something called intrinsic motivation, and it's also about the bandit, multi-unbounded problem. So basically, it's about education game and trying to help student learning how to count, how to do simple manipulation problems, and again they achieve good results for this. Yes, so actually we are in some hard time. We are in this pandemic. So and also this is related to reinforcement learning. It's about psychology, and it's about a flow. A flow is it's about how to be happy. It's a psychology about optimal experience. Only from the life, from happy life. From this point, I'd like to introduce this, and it's also so I recommend you checking this out about this flow, and maybe during the hard time, listening or studying something about this. This is a part of the positive psychology. It may make us happier. And the good thing is, it's not only about psychology, also about maybe this can help us do some applications and using reinforcement learning and using some ideas from psychology to Yeah, for this concrete problem, it helps us, in game design to formulate the reward function. So we use this the idea from this flow, from this psychology to design how to design the anxiety, how to design fun. So when we have this the quantitative definition of those, say, anxiety and fun, then we can formulate the reward. And if we have reward, and usually it's not difficult to formulate the state and action. So when we have state, action, reward, then we can usually formulate the following problem. Then we can pick some algorithm and try to solve the problem. And this is about game design. So we can automatically and intelligently design games. Something also about mobile health, and there are techniques like micro randomized trials. There's something called just-in-time adaptive interventions. I think they are strongly related to reinforcement learning. So I think it's interesting to check this out. And I think this is very interesting in many ways. Healthcare, that's an important problem, and also for reinforcement learning, that's a very interesting application. And there are lots of challenges. I have a couple more slides about the challenges, and some of them are specialized for healthcare. I need to be a little bit faster. Let me see. This is about finance, about stock trading. Yesterday there are some news about stock. That's interesting. But I think this one is for the kind of the long term. It's about the portfolio level. But reinforcement learning is also helpful for short term trading. So probably I just give you some pointers, and if you are interested, you can check them out more carefully. This is about drug design. Actually, I realized this problem. Or somebody talked with me about this drug design problem in 2016. But one reason I didn't work on this too hard is because I don't have enough background in like say biology, like in pharmacy, those things. Otherwise, I think some people have the question why reinforcement learning is not so popular as deep learning. I think one reason is there's no killer application or another AlphaGo moment for the application. But that's a fact. But drug design may be the case. It may. Since one reason is this is a science. So for science, there are objective functions as objective, not subjective, but objective. So it is especially concrete problems to solve, and the goal is objective. So drug design is interesting work to work on. So okay, I discussed some applications just now, many applications. Sorry, I don't have enough time to discuss them in detail, but I think hopefully I can give you some idea that reinforcement learning is actually pretty successful already. So and reinforcement learning has already working well on many problems, but there are still many challenges. So now I'll talk about some challenges of reinforcement learning. Some of these challenges are actually general for machine learning or even for AI, but I think they are also helpful for machine learning, for reinforcement learning. So this one is about software engineering for machine learning. This is some work from Microsoft. So basically, they survey many groups in Microsoft, and then they formulate. They came up with this workflow for the machine learning project. So they see many loops in this workflow. So it's different from the traditional software. So this makes the problem pretty tricky. It's not easy to for example, to debug sometimes. And sometimes when we do model evaluation, we need to come back all the way to model requirement or data collection, to work on this problem again. So there are many issues about the software engineering for machine learning. So maybe we need some new software engineering. Just now we talked about the decision service. So I think that's one effort about doing this software engineering and deployment for the reinforcement learning systems. Yeah, and some time ago, people I think this is I think probably from Google. They summarize some hidden technical debt in machine learning system. This technical debt is from software engineering, the concept, and it's basically about the long-term cost by some short-term expedient but suboptimal decisions about the software system. But so the machine learning system incur those problems, and we need to pay more attention to them. And there are some technical debts, and there are potential solutions. So yeah, and recently there is a big survey paper. To be honest, I have not read it carefully yet, but I think I will read it more carefully later. But I think it's interesting to let you know about this, and maybe people interested in software engineering can work more on this. Especially, I think for reinforcement learning, there's not too much work about software engineering. So I think that's maybe an interesting area for researchers or practitioners. And the figure on the right is actually a figure from a recent talk by Andrew Yin. He talked about from POC to deployment. There's a gap, but this is a full cycle. I think this corresponds to this table from that survey paper. And yeah, this is just some of my idea. Maybe it's interesting to work on data side and software engineering issues for reinforcement learning. Yeah, we try to do something like ImageNet for deep learning, do something, create something for reinforcement learning. And there are some competitions going on. For example, like the DiDi is working on dispatch and positioning. And yeah, this one is basically about the UI. It's something called self-motivation theory. I think that's probably helpful for the human-computer interface, and maybe helpful for your function. So, but people in for example in psychology or on the interface between psychology and say education, healthcare, and also say career, the working environment, they are working on these kinds of problems and trying to use those psychology principles to those problems. Yeah, so yeah, this is, I think, is a very yeah, I don't know too much work about this on reinforcement learning. That means I think that's new. So maybe it's interesting to check this self-motivation theory and how we can combine it with reinforcement learning. Maybe it's helpful for HCI and the reward function. And recently there's a paper about challenges of real-world reinforcement learning. There are, I think, 9 challenges. It's currently there's a archive paper, and we have a machine learning journal special issue, and this is I think it's already accepted, and it should be available soon. This version, the new version, but currently is on archive. And there are people talking about for say robotics, say about sample efficient, generalizable, compositional, and incremental. These are basically trying to make it say AGI. So there's some important components factors. And recently there are some discussion or debate about whether we should put prior knowledge or structure in machine learning. And there are one block from Yuxi Li about bit license and another block from Rodney Brooks about beta license. Yeah, I think that's very interesting discussion or debate. And for Yuxi Li, basically he thinks that these prior knowledge are not important. We should. Oh, I should say that way. So we basically certain things that we shouldn't manually put prior knowledge into the system, and so like the software learn them automatically. For example, using meta learning techniques and using search and learning. But Rodney thinks that, for example, we have lots of things designed by people, and from the human ingenuity. For example, the CNN or like network architecture designs are basically designed by people. But on the other hand, there are people working on doing neural network architecture search automatically. So I think both are just like Thomas Dirichlet. Dietrich said that they are both are right. I think probably there is a spiral progress, and probably one is more long term, one is more short term, and so we probably should learn both from them, both the beta and the beta lessons. Recently, there's a System 1, System 2 that's it's basically from some work from researchers in psychology, but they won the reward in economics, and now people in AI are trying to borrow ideas from those psychological principles. And we have two systems, and the good thing is reinforcement learning is catching up. And recently, people from DeepMind they basically argue that the sample inefficiency and the inductive bias can be addressed to some extent by techniques in reinforcement learning, like episodic, deep ARL, and meta learning. Meta ARL can help address those issues. And I think this is last year's review paper. So I think it's interesting to check it out. Okay, and there are guidelines about reinforcement learning in healthcare, and there are also do no harm. It's also some some guidelines. I think these are for healthcare, but I think that's also helpful for reinforcement learning or AI in general. So I think that's interesting to check out. And there are discussion from business side, like say venture capitals. They are talking about AI is creating an essentially new type of business. So when we want to do startup, we need to think about AI is not a traditional software. Just like we said just now. There are some lots of say hidden debt, and there are also other issues. It's not maybe because of the hidden debt. So there are lots of issues, and it's more expensive to maintain the software, and there are many other issues. So we need to think about AI system as both services and software, and we try to find a way, try to find some business model for AI startups and AI projects. So they gave some advices how to build a great AI startup. And this is from Andrew Yin's talk. It's basically about bridging the AI proof of concept to production. So there are issues about small data, there are issues about generalization, and there are about machine learning code. You can see this small square here. Machine learning code is just a small part of the whole machine learning system. That means the algorithms is important, but it's not. It's just part of the big machine learning system. So there are lots of things we need to take care of, and it's important to monitor changes. And there are say iterating AI and auditing are important for these goals. Recently Dimitri Bertsekas, probably people know he's he has many books about say deep dynamic programming. He's from MIT professor, and he's I think he's father or something. Although I'm not quite sure how to say that. Maybe optimization or something. He's very he's father of say optimization of dynamic programming of So, but he's very I think he's very positive about the applications of reinforcement learning. That's also, give us more confident on going forward about this of this journey. And he said something like, there is an exciting journey ahead for the reinforcement learning applications. And okay, foundations. Yeah, recently, Risatan in a talk, they said AI debate. He gave a very brief discussion about something I think that's also maybe debatable by somebody. He said something like reinforcement learning is the first computational theory of intelligence. Yeah, he's very confident about reinforcement learning. He's kind of a godfather, and yeah, that's but that's interesting to check out. I think that's interesting, very interesting. And recently there's a tutorial in Fox. This is a theory in computer science foundation. I think it's for the foundation of computer science. It's a theory, very theory conference, and there is a tutorial about theoretical foundation of reinforcement learning. So I think it's interesting to check this out about the foundations. Okay, I think these are some. I discussed something. General applications, recent achievements, some issues, and now I think many of these are my opinions. So they are maybe wrong, but something I want to share with you, and welcome comments, criticism, welcome. So when reinforcement learning is helpful, I think when big data are available, either the data is from model, from a good simulator, or from interaction with the environment. For the natural science and engineering problems, usually we have clear object function, and usually we have standard answer. So it's straightforward to model those problems. For the AlphaGo is this kind of problem, and there are many problems in combinatorial optimization, in OR, in optical control, in like drug design. Those problems. I think these are from the formulation wise, from the theory wise, I think these are simple problems. If we have enough resources, we can solve them. And for social science and for humanities, this usually, they are human in these problems, and they are usually influenced by psychology, behavior science. So the objectives are usually subjective, and there may not be a standard answer, so it may not be easy to evaluate, like say game design and evaluation, like education. So these problems are, I think, beyond the reinforcement learning algorithms. We need to find something. For example, how to design the reward function. That's a problem. How to design the object function? That's a problem. So we need to formulate this problem well. And then if we have a good formulation, then reinforcement learning can help them. But I think that's somehow why I mentioned the psychology. Maybe psychology can help us bridge this reinforcement learning with those social science and humanity problems, for example, by defining the reward function. Okay, so just like I discussed here, reinforcement learning, the applications are everywhere, and it can solve sequential decision-making problems. This is basically very general. So many problems are sequential decision-making problems. Some don't seem to be sequential decision, but they can reformulate it as sequential decision-making problems. And reinforcement learning can intelligently automate strategies previously designed by people. For example, say image compression. Say JPEG is designed by some people. People publish papers and then consolidate it to a file format, and many people are using it. But recently people using reinforcement learning to find good comparison algorithms. So reinforcement learning can help automate many such manual decisions. Yeah, this is basically the reinforcement learning where it can be applied. Recently, I updated. Say from the left corner, you can see the computer system. Basically, everywhere in computer science, in computer systems like software hardware, yeah, many networks, yeah. And the right corner is science, engineering, and art. So basically, it's everything. Basically everything we can see in college, in universities. We can find ways to solve them by reinforcement learning. Yeah. So there are some resources. I won't say too much. And recently we have just like in the introduction, we have workshops, we have machine learning special issue. And yeah, recently Chaba talks about math and misconceptions in reinforcement learning. I think it's KDD 2020 talk. I think it's during the deep learning day. So I think it's interesting to check it out. Yeah. And yeah, let me take another maybe 1 or 2 minutes about why the reinforcement learning is not widely commercialized yet. So I think the most important reason is, for deep learning, we see the ImageNet, we see the image classification. So so quickly people catch it up and try to build startups using the image processing techniques to do something. But for reinforcement learning, I think there's no AlphaGo moment. There's no killer application yet. Although there are some successful applications, but not so AlphaGo moment, not so killer application. So I think that's the main reason. Otherwise, we don't need to discuss about those things. People will pour money in. I think that's the main reason. But at this stage, I think it's important to let more people know the power, the strength of this technique. So probably gradually it will be, or sometimes we may have this AlphaGo moment, but I'm not quite sure. But let's see. But there are also other challenges in theory, in implementation. So in algorithms, and there are like issues in software engineering, like in system deployment. And there are business model. When we do this reinforcement learning, maybe it's harder than say AI, than machine learning. People are using some hand design decisions. They are not too bad. Then why they want to use reinforcement learning? There are risks. So there are risks to adopt a new technique. So whether they want to use it, there are some issues about this. And yeah, resources, it's still not sufficient. Like people, like computer, like funding. So on investment, there are some kind of related those items, but maybe they are somehow different aspects. Yeah, for the investment for say VCs, there's a chicken egg issues. When we have killer applications, money will come in. But on the other hand, without enough funding, it's not easy to build this kind of killer applications. But companies like DiDi, like Microsoft, like Google, I think they are doing pretty good on applying reinforcement learning. And it's also there's a slow adoption of new technologies, especially for the traditional industry sectors. And for the technical route, and I think that, most of us are from the AI part, but for some industry sectors, for example, for manufacturers, probably AI people should collaborate with them, or even led by them, so we can make the AI going to help them, rather than AI people lead them. And for the learning curve, reinforcement, I think is harder than deep learning. There are lots of concepts, lots of algorithms to deal with, and so I think there need to have more education and training for all kind of people, engineers, CEOs, and yeah, all kind of people. I think need to know more about reinforcement learning. What kind of issues, what kind of the power, and when reinforcement will be helpful, these kind of things. And yeah, I just want to say no, reinforcement doesn't work. I think there are lots of successful stories already, and yeah, the time for reinforcement coming. But it's still there are lots of challenges, but it's promising, and there are many references. So yeah, that's basically my talk. Okay.
Thank you, Yuxi, for this very quick, and also very high level and very comprehensive overview for what's going on the reinforcement learning thing. And we have some questions from the audience. The first question is, as far as I know, reinforcement learning such as sample-based methods suffered from the sample complexity, and it can be alleviated by planning with model built from the simulation data. In the virtual world, this makes sense. So the question is, how would be the real-world applications such as robotics and auto-driving handle the sample complexity problem?
Yeah, I think since I don't talk too much about many details, I think that's a very interesting question. Sample efficiency. Just now we talked about there's a DeepMind, they have a paper about sample efficiency, about inductive bias. Yeah, people are trying to improve the sample efficiency, and also the question is about simulation, and there's a simulation to reality gap. So I think and it's also about robotics. I think this paper is very interesting to check it out. Basically, this paper provide a concrete solution for this particular problem. They have simulation. They learn lots of things from simulation, and they can apply these techniques to real robots, and these robots can work well on very challenging terrains. So I think there are many techniques people are trying to work on that. And for the simulation, I think one thing I think it's still a hard problem. There's something called system identification. It's very hard to make the simulation high fidelity or close to the real environment, or sometimes it's maybe impossible to achieve that. The real world is so complex, but people are trying to work on this. And recently there's a paper from I didn't put it here, the mu0. People from DeepMind, they extend the AlphaGo to the cases that they don't know the rules. For example, for other games, for AlphaGo, for chess, they don't know the games, but they learn the model from the environment, and they can achieve a very good result, comparable to the previous result, state for art. So, but for that one, it's they have a perfect simulator, so they learn from simulator. And for the games, other games, or Go or chess, the simulator is perfect, so they learn from the simulator about the model. But for robotics, I think there is still I think it's still a very challenging problem. But I think this paper gives very good example solution for this problem.
Yeah, and for the auto,
just one. Sorry, and let me mention a little bit. Let me see, where's that? Yeah, I just now I also mentioned this one, but this is from DeepMind. They talking about sample efficiency. They talking about inductive bias, and this is also another field to check out about that sample efficiency problem. Yeah, this is another concrete technique to this sample efficiency. But there are many papers about sample efficiency. Yeah.
Yeah, I know. Like in auto driving scenario, Nevada or other company, they have for like a simulator environment and try to simulate the environment as close as possible. And I'm not sure whether like Tesla, Waymo, and Huawei. I think they are applying reinforcement learning approach to their auto driving algorithms. Do you know that?
Yeah, I think for the so this is a test bed. This is a simulation environment. I talk with some people from the autonomous driving, but there's about Yeah, I think 2019. You know, the pandemic. For sometimes I have not talked with people face to face. At that time, I don't know they are working on reinforcement learning. They are, you know, like reinforcement, like machine learning, like image, you know, classification, image processing. They are basically working on that, but not reinforcement learning. At this time, I'm not quite sure. For example, say Huawei, they are working on this. Maybe they are. This is a simulation environment. Maybe they are working on some real cars, but I don't know. I recently I have not talked with them face to face about this issue.
Yeah, I watched a YouTube video before, which is given by Waymo. Like they giving quite detail how they apply reinforcement learning in auto driving.
Okay. Yeah, that's fine.
Maybe I can share with you later, and then you can share with the audience as well. And it does. We have other panelists in discussion in today's discussion as well. It's Tony or other people have more comments on these questions. Yeah, you can just unmute yourself, and if you want to comment, adding more comments. Yeah, Tony.
Yeah, so I think a particular thing about applying reinforcement learning to industrial scenario is that you know, whether it's business decision maker or engineers, people are very careful about the quality assurance of the policy deployed when it's first deployed to the production system. So so I'm wondering if Yuxi, do you have any comments on that aspect? Like how can we how should the development of reinforcement learning algorithms gear towards that, so that it's more friendly for industrial deployment?
Oh, can you make it? Sorry, can you repeat a little bit about your question?
I'm just wondering about what's your thoughts about the direction for the development of reinforcement learning, so that it becomes very friendly for industrial deployment scenarios.
Okay. Yeah. Actually, I think you are expert. Okay. Anyway, yeah. So far, since mostly I'm from to be honest, my experience are from reading papers and talking with some people. So I think basically, you know, say I think this is one resource I recommend people to check out. And yeah, also the paper from DiDi, I think, since they are working on the real problem and apply to the real system. Yeah, I think this paper is very good, and also the tutorial by Tony. And for the Microsoft, I think yeah, they discuss many of those things. There are many issues, but you know they design this kind of the abstraction of the system, and from the software engineering perspective, and then they implement those using the software, the code, and then they, you know, address those issues in the systems. But you know, there are already also some issues like we discussed them a little bit. For example, like from Anjuin's talk, you know, the machine learning code, also reinforcement learning code will be just part of this big reinforcement learning system. So we need like you said something like say friendly or people easier for people to use this. Yeah, I think there's something here it doesn't say is these days people are talking about GPT-3, right? And one thing is GPT-3, they put OpenAI put this on for people to use just the API. So some people are talking about this API kind of machine learning, but that's not easy. Software people basically can call a library and using API, but machine learning so far is not there yet. Although people are working on that, like AutoML. Say GPT-3 is kind of a concrete system. They can put it they can put it on cloud and make it accessible to people. Just use the API to call the GPT system. So I think that's one thing. So it plain AI and if possible API like, but I don't think that's easy, especially for reinforcement learning. And there are people talking about, say, the cycle. Let me see where I put it. Well, just now I mentioned something about the deployment. So I think we also need to consider those. So I think it's still very very challenging. Especially for the software system. So yes, I think for me or for us, I think we need to check those things out. But sorry, I didn't give a simple answer. But I think there are still many factors to consider to make it deployable, to make it in the deployment system.
I have a question for Tony. Like in DiDi, would you mind to explain a little bit more, like how DiDi is using reinforcement learning for scheduling or other problem?
Yeah. So Yuxi have one page of that about the order dispatching matching application. We are also working on using reinforcement learning type of methods to basically to help drivers to make decisions about where to navigate when they are idle. So this is more like a driver assistant type of application. So that is to help drivers to achieve a better financial goal. So this is something that we have also been working on a lot, and is a very important aspect for the ride-hailing or ride-sharing marketplace. Yeah.
So it's this system in production, or it's like in prototyping stage?
Yeah, we actually have deployed a number of times for real world pilot testing already. So it's and we have seen very positive results from that.
Okay, so I believe for like reinforcement learning thing, as long as you can define the reward and define the states clearly, then there's many applications, and this application have a bigger kind of financial return you can get, right? So I personally, I little bit question about like reinforcement learning. It's not very applicable for now. I'm not sure why people are saying that, because I think there's many problems like DiDi, like as long as you can clearly define the reward and clearly define what's the state it is and what's the action associated, then it becomes quite a little bit obvious. I'm not sure, like Yuxi or Tony, what's your thought on this? Like it's
I'll
really.
leave it to Yuxi.
Oh, sorry. Can you repeat? Sorry.
Yeah, my question is, I think in our real world, there's many like this kind of scenario, like you can quite clearly define reward and define states and define actions. So the reinforcement learning can apply to these scenarios. I think it's quite somehow conceptually it's straightforward. So why like the reinforcement people are seeing reinforcement learning application it's not very popular yet?
Yeah, so basically I'm trying, this is my, I'm trying to, I wrote a blog on Zhihu. Basically I'm trying to understand why reinforcement learning is not so widely commercialized yet. This is basically my answer. So yeah, there are many factors. I think, the most important thing is resources. But another thing I think, maybe to make it simple, I think is that's why I put this education and training also here. I think we need to let them know that reinforcement learning will be very helpful. But there are still some obstacles. For example, I don't want to make enemies, but when we're trying to do supply chain is usually by people from OR, and mostly OR techniques are pretty good. Although I believe reinforcement learning can be better, but is that very better or just marginally better? So that's maybe the issue. If you just say 1% better, maybe that's not so attractive for people to do that. But if it's like 30% better, then so maybe there are still the reinforcement learning in some cases is still not so good yet. But on the other hand, maybe the reinforcement learning doesn't have the chance to show the strengths yet. But basically this is my, I think, this is my answer about why reinforcement learning is not so popular yet. But the key reason is there's no, I don't think there's a killer application yet. Although there are some good, there are lots of successful stories, like from DiDi, like from Google, like from DeepMind, but no killer application yet, and no AlphaGo moment yet. Otherwise, so sometimes I think that's basically like the herd, right? Herd. So it's really for for common people. They need some kind of AlphaGo moment to, like say many VCs probably they need this kind of AlphaGo moment or killer applications to pour their money in, rather than now we are trying to convince them, but to convince some people sometimes it's not easy. But if you have good, say like maybe Tony can say something why DiDi can't do this, so who convince whom, or something like this.
Yeah, I think I agree very much about your last point on more education training, for reinforcement learning to be adopted more widely. The one difference from deep learning is that reinforcement learning, that you have to put in a lot of thought about how to formulate the problem, how to set all those the different aspects of the MDP model, for example, and they all contribute a lot to the final success of the application. So that's where the more education and training comes. And also communication is important, since reinforcement learning is, as Yuxi said, the renaissance. So it's basically it's re-emerging in the recent years. People may not necessarily have a lot of knowledge about that. Not to mention people not working particularly on this topic. So it's important to set the right expectation especially for the decision makers, and also to acquire the necessary and appropriate resources. So this is, yeah, I think I'm all very agreeing on that particular point on your slide.
Yeah, it seems to me, I think all this challenge or question is common to AI. Like people are, like even for like just deep learning thing, I think facing the same challenge as well. So, but probably reinforcement learning, it's even more challenging. Like the question becomes even more obvious. But in general, like in the industry, especially in the traditional industry, yes, still like people are not familiar what AI can do. Like even like very simple, like image classification problem, most people don't understand how useful this technology can be, like for the traditional industry. So I think this challenging it's common for AI. And the next question, like even for deep learning, do we have killer applications? Like maybe like face recognition, face detection, it's one like big applications like that. But other than this deep learning or in general AI, it's more assistant to the traditional business. It cannot be it's a business by itself in some sense, right? What's your more thought on this? Yeah, I think this thing is kind of common as the AI thing. Yeah.
Yeah, I think just now there's related to several slides I mentioned. So I think basically for natural science and engineering, I think basically it's easier to apply reinforcement learning. I think AlphaGo, like I think the DiDi is, although the business in DiDi is complex, but basically I think they have some clear goals. So that's relatively easier to do. So but for social science and humanities, it's basically not that easy. And following from this, I think just now I mentioned one particular application. I think drug design. This may, I think this is a very important problem, and people have already worked on something about this. And maybe at this stage is in the stage of commercialization. And this is this may if they have some good results, for example, for this one, or for the mRNA, or for even the AlphaFold, people may use reinforcement to work on those problems. And this I think this is a potential candidate for the AlphaGo moment. That's my thinking. Otherwise, actually, reinforcement can be applied many places. And but for the say breakthrough level, I think those drug design like AlphaFold, like mRNA, those kind of problems, I think they have some good potentials for breakthrough results. But for say problems in in OR, in those like in say transportation, like I read the paper, I think it's about say 2% or something. That's very good result for a DiDi level company, but to draw the attention from the public, that's hard. So for the say for common people, for the newspapers, say 2% improvement for transportation for red hailing. But that's not quite easy to have this kind of AlphaGo moment. But if we can say solve the AlphaFold problem by reinforcement learning, or we design some new drugs by reinforcement learning, that may catch many people's eyes. Yeah, that's my thinking. Yeah.
Okay. So one thing is still quite interesting to me and I want to ask Tony, it's like in DiDi's application. So how did you like collecting the training data, or you just using the simulation for training, or it's you using some kind of historic data to train your reinforcement learning model?
Yeah, we have an abundance of data logged from the production system, basically historical data. That's something that we have heavily leveraged on, and at the same time we putting efforts on the development of a sophisticated simulation system, so that we have something to basically to evaluate the policies that we learn. So I think both are definitely important for the development of reinforcement learning applications in industry, and then they have to go hand in hand. Yeah.
Okay. Yeah. Thank you. So, do you have other question to ask from the panel, or more thing to discuss? Yeah, if not, then we will close today's event. And thank you everyone to attending, and special thanks to Yuxi to devote his valuable time to us and to share his thoughts and all his knowledge with us today. And thanks to Tony to share your perspective as well.
Yeah. Thank you, Yuxi and Li Han, for the very informative talk and insightful discussions on this topic of reinforcement learning applications. Yeah, I think there are a lot of materials presented today, and I believe everyone has a lot to take away. Yeah, thank you.
Yes, thank you for attending. Thank you for organizing, and thanks Li Han for leading the discussions. Yeah, thanks a lot.
Thank you.
Thank you. Bye-bye.